hit the record button. It is the end of January, and yeah, so I think we're going to let a couple of other people join in not too long from now. Anshu, I see that you've added a couple of topics here. Let's get right into it. You want to, yeah, let's get started.
Yeah, let me try to explain it. Let me try to formulate it. And let me open my okay. Give me yeah, can you guys see my screen?
Yes.
Okay. So here I've been analyzing individual service and their relationships. Right? They get me RDS, get me S3, which has certain parameters or attributes like public, private, get me EC2, which is extends to public, you know, some of those queries. But now, so let's say I'm going to start drawing it. This is S3, this is EC2, this is RDS, one, whatever, right? And they have some attributes, certain attributes associated with this, right? Similarly to EC2, similarly to RDS. So we are able to query individually. But now question is, what is the best way to establish relationship between inter-service, right? That, hey, this EC2 has access this S3. This EC2 has access this RDS, right? So, or this, you know, this RDS, other example could be, is putting the data dump. This could be RDS or any DB, it doesn't matter.
Sure.
Yeah, data dump into this S3. So what is the best way? That is the problem number one that we are trying to solve, that we are able to solve all of the individual labels that, hey, show me S3 which has public bucket, show me, give me RDS which has this security group, and exposed to public, all of that. But now we want to see, give me EC2 and what's the blast radius for this EC2, right? Yeah. So how do we establish that? Right? Yeah.
From a permissions perspective, the way that we represent that is an EC2 instance has an IAM instance profile. And so the IAM instance profile will, it determines what role that the EC2 instance will be able to act as.
Mm-hmm.
And then so effectively what happens there, we have exactly, so like we have the EC2 mapped to an IAM role. There is a analysis job in cartography that draws that relationship. And then once you have that mapping from EC2 instance over to IAM role or IAM principal, then you can get a relationship from that IAM principal that says can read, can write, can execute on the data stores. So you have something from IAM over to S3.
Mm-hmm. Mm-hmm. Yeah. Okay. So let me show you one. Yeah, that makes sense. So that was one of the information I was looking at. So for IAM, we are able to map. So this is just a screenshot, so I cannot do active drawing, but just to give you an example. So we have mapped all of the IAM groups roles into their policies, their risk, and here we are showing the hey, this policy can be used to modify EC2, access EC2, or access S3. So we are able to link from user to the actions, right? And similarly, we can link from service, which is EC2, to their actions, correct? Now on that, so let's say we get this service profile. So it means by using that, we can figure out what different services this user can access or this EC2 can access.
Correct. And there, we wrote a blog post on how that process of mapping from IAM principles to the resource happens. I will paste that
Mm-hmm,
right here in the meeting notes.
mm-hmm,
So, and then so like basically, yeah, the relationship from IAM principle to resource that happens in this
yeah,
post right here. Yeah. Um, yeah. So if you look at the, I'll paste it in chat also.
yeah. I think,
But yeah, check out that blog, and then because it shows like how we do that mapping from IAM to everything else by evaluating the policies and the resources, and then we go through some interesting logic to make that happen.
mhm. Yeah, let me pull it out. Is it on Slack post or where is that?
I pasted it in the
Oh,
I pasted it in the meeting minutes and in chat. Yeah, yeah, right here. Yeah, so this
right.
thing.
Okay.
Yeah,
Yeah, let me see.
yeah. We are doing a little bit of maintenance work on that, just adding some. We added that feature maybe a couple years ago. We are right now adding some extra tests to it because it's kind of a yeah, exactly. Yeah, so if you scroll down a little bit to the, there's a good picture here that summarizes all of it. A little bit more down, little bit more. Yeah, right here, right here. Yeah. So essentially, this is it basically. So we take like all of the principles in the graph and all the resources in the graph, and then we define a set of permissions that a cartography deployer might be interested in the form of a YAML file. Because if you were to like do all these mappings for everything in AWS, that's just not feasible. So we say that okay, we're interested in the mappings to S3 buckets, and then we say that if a principal has S3 get object for a given resource, then I want to define that relationship between them as can read, and then so our logic will go in there and do those evaluations, taking into account the policies and then the resources and then like evaluating things like not action and not resource or whatever and all those complicated things. And then if after that order of operations it determines yeah we're probably should still draw that relationship, it'll go ahead and do that.
No, makes sense. So these all of the relationship, these are, do we write all of these jobs and the relationship, or this comes with the, this is all, there is already script. So cartography pulls all of the data from AWS, then there is a script which runs and establish all of these relationships.
Yeah, correct. So the order of operations here is kind of yeah, cartography takes that into account where uh, I guess if you run a very vanilla looking cartography deployment, what will happen is everything will run one by one in serial. So you'll get all your data stores, all your S3 and everything else, all of your IAM principles, they'll come at some point in that chain. And finally at the end, or toward the end, we'll do what we call the resource permission relationship sync. And what happens there is that it'll take all that information in the graph, do some extra evaluation, and there you go.
So we were planning to write our own job, um, or the own mapping. So it means it will be better if we can use the pre-built because there are so many contributors like you guys have done. So is that where is that code? Where the mapping is there?
Yeah, it's if you go right back to that blog post,
Okay,
the link was like right there. So yeah, so it says as seen above, what yes, resource permission relationships file right there.
okay,
Yeah.
yeah. So you guys have created the YAML file which defines all the relationship, and then your script picks up and do the whole. Is that okay? Okay, yeah.
Yep. And then for custom things, a cartography deployer, you can define your own.
Yeah.
Internally at Lyft, we have like several others, but this is just an example for
Mhm.
things that for things that the largest amount of the community could find interesting, we thought.
Okay, okay, gotcha. Where are the others? So these are all of the other jobs with YAML. These are JSON
These
files.
are different. Those are cleanup jobs, which is basically making sure that the data in the graph is fresh at any given time. And
Mm-hmm.
analysis jobs are kind of like it's similar to that. Only analysis jobs don't use any Python code. They use strictly Neo4j Cipher queries to add in extra attributes or draw in extra relationships. It's like a post-processing job, but it doesn't use any Python.
There is a pre-processing where, all of the, so yes, thanks for showing it this permission relationship. But there are others like, all of the relationship for AWS, GCP, all of those kind of YAML file where you guys are feeding into the system. The
Uh,
data modeling, yeah, data modeling.
there is no data model right now, but that is in progress. So
Mhm.
um, the yes, so the only YAML configuration that happens right now is that permission relationships thing that you saw.
Mhm.
We are in progress of implementing a new graph data model to make it a little bit more structured. So we have our own sort of ORM light that we've kind of implemented.
Mhm.
So if you look at, let's see, what's a good example for this? Let me think. I'll point you toward the PR. This is pretty, I guess, bleeding edge, I guess. So if you click on pull requests, and then if you look at this one at the top, organized data models. Yeah, and then so if you go to files, changed at the top, yep. And then so essentially under, I guess as an example, if you go to cartography graph models AWS. So on the left side, there's like all those files. Yep. And then you click on emr.py, AWS emr.py. So AWS folder. Yep. You got it. Yeah. So like this is kind of an idea of like what the direction that we're going. So um, prior to implementing this data model, so we kind of we kind of brainstormed many different ways on how we could abstract away a lot of the Neo4j queries and make it a little bit more easy for other people to add in new data types, because handwriting your own Neo4j and then adhering to all of our various conventions, it's not the best dev experience.
Yeah.
So one thing that we added recently is this sort of data model that we're experimenting, and then so far the only module that we've really refactored, we're trying to get the EMR module to be very clean and understand everything before we deploy it to everything else. But
Mhm.
so the basic idea is that we have this uh, this data model that defines, okay, this is a node, these are the properties defined for that node, and here are all of the relationships that can be attached to that node. And then like this gives us some really cool things too, because once we have that structured out, we can do things like, oh, here's automatic index creation, here's automatic cleanup job, here's possibly in the future automatic documentation generation. So things like that get unlocked, and then like maybe even like automatic parallelization and other interesting things too. But this is sort of the direction that we're heading. You asked about, anyway, going back to your question. Your question was asking about like, oh, where are your models and things like that. We don't have any, but then this is the direction of
Yeah, no,
going.
this is good. So happy to contribute. So then, since you mentioned you don't have models, how all of these models getting created initially? Because you're
By
in,
hand.
hmm?
Yes. Yeah. So by hand. So like if you so prior to implementing this model, what we do is that if you look at in the code, so in the cartography.intel.whatever, there's more than one, there's like multiple Intel modules or plugins, as we say. Yeah, so under cartography, Intel, and then like any of these files, basically.
Hmm.
Yeah, and then so like a number of different plugins. So if you could click on like any of them, essentially what module developers have been doing is a lot of copy pasta, and like taking a lot of we follow a set of patterns where it's like, oh, you have a get function that'll grab from your upstream provider, a transform function that will massage the data to a format that makes sense, and a load function that loads it to the Neo4j graph database. And a lot of it has been, all right, well, we need to kind of hand review everything pretty extensively. Not great reviewing experience either, but that's what we've done. And then so like and in the documentation that we've done on our schema, if you look at it under docs and then like our data model under schema, well, we can look at that too, actually. So if you go to the main page, so like at the very top, yep, and then on the, sorry, if you go, yeah, back, and then on the right side where it says lift.github.io, yep, so do that. And then under schema, so I think it should be maybe, okay, so if you go to Intel modules at AWS, just as an example. Oh, oh no, you had it.
Oh, this one, right?
No, you had it in that that other page.
Wait, I came out. Yeah, this is AWS.
No, the one where the GitHub.io page.
Okay, okay.
Yeah, and then so if you click on, yep, and then Amazon on the left hand bar where it says Amazon Web Services. Yep, and then scroll down. I think. Oh yeah, I'm sorry. Yeah. So if you look on the left bar, where it says AWS schema. Yes. Yeah. So this is like the reference document for every single, I guess, relationship defined for every single data type that we have, and this is hand maintained.
Yeah, and you guys have already defined that, correct?
Yeah.
And that is coming from here.
Yeah, but it's and then it's implemented there, and then but you know, the document is manually maintained.
Yeah, yeah, yeah. This is something like we are trying and happy to collaborate as well. You know, my developers can collaborate. We're building something very cool. You can run query end to end, any level of queries. Yeah.
Cool.
So other question. So on this one is already live. This is like if we just fire up the cartography today, so this will come out of the box.
Yeah, that this exists.
And this exists, and then okay, and this is then we can query this level, right? That hey, for EC2, what's the blast radius, correct?
Yeah.
Yeah.
You may need to do some, let me think. Yeah, so like what the query would be from like IAM over to like S3 or IAM over to a database or something like that. The other thing to think about too is that typically, like, one other extra detail is that when you go from EC2 to a IAM role, that IAM role typically is something like an assumed role, or which is like a, or at least it's something ephemeral or temporary or whatever. So you might need to do one more level of indirection. So it'll do like EC2 to an IAM node, and then so from that IAM node, you'll need to make a query from that IAM node to another IAM node, because you'll want to see like its trusts. Yeah, that relationship will be like, is there a trust relationship between the two things? Yeah, and then you'll be like, okay, well, from that thing that trusts the IAM instance profile, then what other resources can I exploit? And yeah.
Yeah. Yeah. No, I'm very, very well familiar. In fact, we have built our the whole IAM module, and this is part of. I'm happy to show it on the call as well, but you might have already seen it, so I can show that. And that is where we want to take the whole thing to the the graph DB, because the queries are getting very complex. So here, let's say pick any user. So any user, we are profiling the risk that this user has, these many risks into these many service, and then how these risks are flowing into this. So
Neat.
all of that. Yeah. And then you can take what actions user can take on this, they can delete all of this. So now this data we want to map it to the resource, and then from resource the other way around as well.
Okay.
Yeah.
Yeah, cool.
Okay. Cool.
These are good questions.
Yeah, I'm very deep. Yeah, going a little bit deep into the graph. So thanks for helping us out. Which cloud security tool you guys use?
Um, that's a good question. Uh, Cartography.
That may not be enough. I was
Exactly.
watching video for Shasha. Yeah,
Yeah.
because that will not tell you the risk for given IAM user. But anyway,
Yeah. There's a number of different what you call we have a number of different, I guess, workflows that will pull data from like our graph and various different sources and then just kind of correlate them and put them in the form of like reports or dashboards or
mm,
whatever we need. um, that kind of thing. But it's all like super super custom. That's unfortunately not super open sourceable. I wish it was, but um, you did have another question about GitHub the service. Did it? Should we talk about that?
yeah, yeah, we can. So let me pull up my question.
Oh yeah, this is a good segue for that. I think I know exactly what you're going to ask, and then this kind of goes back to that point about things that are not super open sourceable. Yeah.
Okay. Yeah, no, no problem. We'll figure out. We are all engineers. So until this part, it is very, very clear to me, right? We have this data. We already have this data. We are already doing analysis. This part is very clear to me. This we are already doing analysis. The only this part is not clear to me. So how you are establishing the GitHub repository service relationship with auto skill group automatically. Manually, I know. Yeah. So
Yeah, the tricky part here is so this schema that is shown on this slide is very specific for Lyft. Um, Lyft has we have like we run microservices and then we have a set of very custom plugins and modules that draw this mapping from a service to what GitHub repository maps to it.
mhm,
And unfortunately, this is something that's going to look very custom for any organization that has their own notion of what a microservice is and like how they want to set up, like where that state is going to be saved. For us, we save that state of what a microservice looks like. We save that in like some JSON blob, and then we're able to kind of like take advantage of that with our syncs, and we have like a set of custom plugins and custom sync jobs that handle all of that. So this is something that like it would be really interesting to see like if there's some, I guess, scaffolding out there in the industry or some industry standard that defines a microservice. But like, yeah, this is all very very custom.
okay. So it means from GitHub repository. So this is deploying to service mesh or anywhere, right? It could be proxy or anything. So in your repository itself, you are saving some state that, hey, this application belongs to this service or something like that.
Correct.
And
Yeah.
then, yeah, if that is there, then it can, yeah, it from Envoy or anything, it can figure out the route.
Correct. Yeah, you'll have like some, I guess, central place where all of your definitions for all services and all of the mappings to other
Yeah,
entities, like the GitHub repo or like on-call policies. And if you can take advantage of that centralized place of storing all of that, then
yeah,
you
yeah,
build a cartography module on top of that, and that will look very different for every company.
yeah, yeah. So it means like, that was my fear that, hey, if we're going to ask customers to define that manually, it may not fly. So I was looking for some automated way, but so unless we save some state, there is no way, right? Yeah.
Yeah, like if you can, I don't know if I'm not really familiar here. Like maybe there's some uh, industry standard way. I have no idea. I would love to learn.
Yeah. Okay. Yeah. No, no problem. Yeah. Manually, it's possible, right? Just if, as long as you can define this link, you can query anywhere to anywhere. Yeah. hmm Yeah. I think these were kind of my questions.
They're
Yeah.
good questions.
So we are building. So now in the next phase, this is end-to-end query. Our product is being utilized into lots of big corporations like GE and all of this. Now this is the next step where free-flowing query anywhere to anywhere, and we are linking We have our DevSecOps product. We are linking your DevSecOps data to cloud. So code to cloud journey, that is our vision.
Yeah, that's awesome.
Mhm.
Uh, Being able to create this like question answer service that's essentially that's the goal of the project.
Yeah.
Awesome. Um, Very good questions. Thank you for asking them. Let's see. I don't know if I have extra top before I think about like anything I want to add in. Ramon, do you have like other topics that you want to talk about?
Hey there.
Yep, I can hear you.
Other topics. Did you already sound a little bit late, but did you already announce the some of the upcoming features that we have, like automatic cleanup jobs, and yeah, that's the major big one, really. And some of the new sync modules that are coming that I'm more interested in, such as LastPass. You know, there's a concerning LastPass read. So some of the data in there, if you are using LastPass in your work, I think could be very useful. That's all.
Yeah, good call outs. I didn't really talk in detail about auto cleanup jobs, but I think that Anshu gave when he asked the question about like where are your data models, we sort of like did a brief like diversion into that, talking about we're building a data model. We're not entirely sure like what's going to look like. We're testing it out on EMR first, and then with like I said, with that, it gives us the opportunity to build things like automatic cleanup jobs where um, did I talk about this in the last meeting? Uh, no, we didn't. Oh, so that's exciting. Okay, okay. I can go into that very briefly. And PRs in
Hold
progress.
on, hold on. I just want to say how excited I am about this because we did not start out wanting to build an ORM, but it's
To be fair,
evolving
it's
into
not
that.
an ORM. It's not an ORM. It's kind of like an ORM. Yeah.
We'll feel real good when it turns out into a full-fledged ORM, though. Like,
Well, I think I need somebody that knows a little bit more about compiler development than myself. That's what it's turning out to be. Okay, so let me, while my other thing is trying to load right now, okay, I'll talk a little bit about automatic cleanup jobs. Okay. Yeah, so like I said, one of the cool things about being able to have everything represented in a set of data models is now instead of needing to handwrite a cleanup job, so determine like which of these nodes or relationships on the path gets stale, instead of like handwriting that, and then there's so many points where you can have a typo in here and then it'll ruin your day. And the order of operations of this actually matters. And then there's so many little weird subtle things that we have been burned on in the past. So one of the cool things that happens now is like all you got to do is just define call this and then put in your node schema here, and then it'll all be figured out for you. So how do we do that? And then I won't go too much in detail, but the basic idea is, how do I make this nicer? If I go to, let me just view this file and I kind of talk a little bit about the theory here. So if we grab one of these node models that we have here, so this is for our this is a node schema for EMR clusters, and then it has properties and it has one or more relationships. And so with this structure, now we know that, okay, well, we are going to eventually want to clean up the EMR cluster. But before we do that, let's make sure that we clean up any things let's clean up the stale relationships also that that it can be attached to. Like this maybe not like the best example, but you can imagine that this is an example of a cluster to an AWS account. You can imagine that there may be other relationships like EMR cluster to something else. And then like if that relationship goes stale or if that relationship changes to something else, then we'll want to clean that up so that you're not having old state in the graph. And so what our code will do is that it'll sort of traverse this data model. It'll traverse the schema, be like, okay, well, what are the relationships that are defined on the schema? It'll go and be like, okay, well, this is one such relationship. Let's clean them up if they're stale. And then I see no other relationships that are stale. Let's go back down and check, are there any EMR clusters that are stale? Let's go clean that up. And so essentially what happens with our logic, if I can go to the tests, it's a little bit more understandable to go here. And I think there's one where I list out, where I put a big list, and this is ending up a little bit bigger than what I intended to show. I hit apply and reload, and then if I go to here, and anyway, this is, oh yeah, here we go. Yeah, so essentially what happens is if we pass in build cleanup queries for a given node asset, this is the set of queries that will be automatically generated. You see that we will first take a look at all the relationships that are defined on this asset, and then it will kind of traverse the entire, all those things that are available, and then make a set of cleanup jobs that that makes sense in the context of cartography. And yeah, that's about as much as I wanted to talk about that without, yeah, because we can go super deep on here. Any questions? Okay. And then the next thing, well, let's see, PRs in progress. I think in particular, Ramon, you wanted to talk about the last past PR. I will preface this section by saying that we are behind on reviews for the community, and we're doing our best, and we will continue to push forward. We really appreciate the contributions. So this one on LastPass will help us out.
If the community wants to help review the community, right? Yeah, please do so. Please.
Yeah.
Like if you're already familiar enough with like cartography code, and you maybe haven't said hi yet. Yeah.
So I can. I was exploring memgraph. We started memgraph and started create our own data model. And yes, I was aware of cartography, but maybe I was misinformed or something that hey, it's not gonna solve our use case. But looks like some of the use cases that we are doing, you guys have already done it. So rather than re-implementing those in memgraph or something, I just started to look at this, and I will have some of my developers, start to play with this. And if we get enough interest from our side, then happy to own or happy to contribute to data model. And slowly, as we are getting more familiar with cartography, maybe I can ask some of my developers at least to start commenting on the PRs. Right? But they are just familiar with AWS so far.
Cool. Yeah. Let's continue talking on Slack, and then let's see like if we can maybe divvy out a part. It sounds like you'd be interested in helping out with the refactor, right? Like converting like all of the old style and then incorporating the data model.
Yeah, because we are building it anyway, right? So the whole IAM we have built it. Now we are taking it to the next level. So we are building it anyway. Yes. Right now it's just for demo purpose. Whatever we have built, it's quick and dirty. But as soon as we are able to establish all of the links, then we will be able to look into the cartographic relationships. How you guys have done it. Yeah.
Cool. Yeah, this is exciting.
Yeah. You both are in Bay Area, you guys.
Say again, please.
Are you guys in Bay Area? All of both of you?
No, I'm all the way on the East Coast.
East Coast? Oh, where?
Virginia, close to DC.
Okay. And how about you, Alex?
Seattle.
Wow, that was my old home, Microsoft. I used to work. You live in Seattle or the east side?
I'm in the city. Yeah.
Very, it's very rainy. Cool.
Awesome. Yeah, thank you for offering to do that. And we will. I made a note. We will follow up offline on those refactors, and then probably have a little bit more for you once we kind of get these core pieces done, like get the auto cleanup jobs done, and then get the uh, next thing is like automatic indexes. I haven't submitted that PR. I'm like basically ready to do that. But I don't want to overload our.
Mhm.
I don't want to overload Ramon on that.
Um, okay, yeah, automatic indexes and oh, you're gonna add like a little option in the schema to say like, oh, I want indexes on this other property as well.
Yeah. Yes,
Okay.
I have that. It's done. Like I'm ready to go, man. The well, one of the things that is, I think Ryan talked about this a little while ago, was it's kind of annoying where because we create indexes on like everything that's possible, even if you're not going to actually load that to the graph. Like when you go to the Neo4j UI, you're like, oh, I got all these Azure things, but I don't even run Azure. Like what the heck, you know? So like if you this index PR will let you do is that we will only create the index if the code actually runs to that part, if that makes sense. Wait. Let me think. I don't know if it actually does that. I might be over promising.
Because
TBD.
like, yeah, every code path should be reachable.
You're right. I'm
Yeah.
I'll have to rethink on that particular promise, but there's
But are the indexes harmful though? Like even like if you don't have
no, they're
Azure
not
data.
harmful. They're not harmful because like if you don't have any data, there's nothing to really index, so it's going to be like an empty thing. It just kind of crowds your Neo4j web UI.
I see. Yeah.
Yeah, so low priority, not super important, but
So,
yeah.
so one last question. So on this, if you need to start whatever you have, right, all of the relationship, because cartography is currently working, it's able to query end to end. So I'm very, very interested because I believe until and unless I understand the current data model, queries are secondary, right? We can write it, right? But so where is the starting point to review the current data model for AWS? Is this the right place to start where all of the relationships are established for different services?
If you're gonna try to review the data model, I would actually start at the schema docs.
Schema doc. Yeah, this I have reviewed it. It's
Yeah.
very clear. But in the code, I want to, because now I want to map this to the code. Where is the defined the code? Is it coming from here?
Yeah,
Yeah, so
usually the load functions that you see there. Usually, some of it's been not done in a great manner, but yeah, for most of it, yeah.
Okay. So
yeah, so like if you look at that, it's like the answer to your question is basically just by reading the code, unfortunately. So like any load function is going to give you an idea about like what the data shape will look like. So you'll see here in that load function, we have, what do we got? We got a cluster being mapped to, if you scroll down a little bit, mapped to a AWS instance, AWS account, basically.
yeah, these are several examples. Okay, so everything has a load function, and on the init, you load all of these you call all of these load functions, and they just create all of these relationships. Yeah, right. Yeah.
Yes, and then for some of the older ones, there might be attach functions, where after the node itself is loaded, we load in some relationships to other nodes. Yeah.
Okay, and where all of those load functions are getting called in init file or something main file?
No, they're all so the structure of an Intel module is basically, it's all copy paste. It's all like you have a get, you have a transform, and you have a load, and then that's all in that plugin. If you go to the that GitHub IO page with the documentation, if you go to, let's see, so there's developer docs under, yeah, how to write a new Intel module. And then so this kind of talks about the pattern that's used. And then so yeah.
Yeah, this is, yeah, this load is clear. Defining a node, this is clear, this is clear. And then how do we link these load to where? Is it a main file or something?
Oh, I see. I see your question is. Yeah, yeah. So like how is all of this orchestrated? So you'll want to look at sync.py.
Yes.
Well, yeah, actually, let me think about this. Yeah, so sync.py, you have it on that page right there. And you see like there's a number of sync stages. Actually, so this is like sort of the class that defines a sync, but it's not like the sync itself. The idea is that we have a number of sync stages that you will define, and then we have like one for AWS, one for GitHub, and then like that all gets run.
Okay, so this is this one. Okay.
I think if you scroll down to the bottom, if I recall correctly, there might be a default sync. Yeah, there we go, there we go. Yeah, so this is essentially it. So this is the default sync that gets run.
Mm-hmm.
And then it all gets run in serial, and then
Yeah.
Typically, if you've got a very serious cartography deployment, you will want to probably build a custom sync, and then we have documentation on how to do that too.
Yeah, definitely. And would you recommend Neo4j or memgraph? Neo4j is very, very expensive, right? Or we can just use the community version.
I have no experience on memgraph, but like from I've seen some of the I guess recent posts on like Hacker News and things like that. It seems interesting. And then like I think there's another blog post about how you can like literally take a Neo4j session object, throw it to let it talk to memgraph, and that seems kind of cool. But no experience, can't really talk there.
I saw something about someone also trying to use Neptune, AWS Neptune.
No. Amazon will send you this much bill. Amazon will send you this big bill, right? Do not
expensive.
Amazon, Cosmos, Neptune, Cosmos, they, Amazon will get you in just for $1. Yeah, and then
no free tier.
Yeah. But we can run Neo4j in the Docker, our own Docker, right? Community version.
Yeah.
Yeah. The only I guess drawback there is that you would have to figure out how you're going to do backups and other things like that. But yeah.
All right. No, this is very interesting.
If that's important.
Yeah. So let us play with it, and we will because you guys have done the heavy lifting, right? Looks like by looking at it, we need to establish a little bit more relationship because all the heavy lifting is done, and then create a nice UI or user-friendly UI, which so that analysts or security personnel they don't need to write queries, right? They just click. Yeah.
What kind of things do you want in this UI? In your UI?
Yeah, in my vision, let's say you are a security analyst, right? You don't have to care about Neo4j, how do I write match query, something. All you want when you're sitting in security operation command center is, hey, there is an incident, select incident and give me the resource which has access to public, just a kind of wizard, right? Hey, I'm thinking an example. Get me an EC2 name. They just input the name, right? Which has and it pure English queries, which has access to this S3 bucket, right? Has access this S3 bucket and write some piece of content, some file. So that kind of a click kind of a question I want to build.
Okay.
Yeah. I think let me see if I have an example.
Like if you have an incident, you can quickly answer some, possibly common questions. Right?
Yes, yeah. And I'm trying
with the UI.
That will give you
Yep, that was the original. Well, that's one of the goals that big knowledge graph lets you answer.
So for example, we're gonna build something like this. Query will be behind queries. So some UI like this has an instance of, public, is in virtual machine, has, port status is closed, has some CVE related to this, something like this. So that, you don't need to worry about onboarding into ciphertext or memgraph or something. Everything is behind. You just click that, hey, give me this virtual machine which has port close, which is deployed on AWS or GCP or something like that. That's what I want to build.
Cool.
Okay.
Awesome.
Yeah.
Yeah.
No, cool. We're trying. Good. It's coming good.
Yeah, definitely. Definitely excited to see like ways that we can collaborate, and then especially when it comes to like a data model and whatnot. And then, as always, like yeah, these are good questions, and then this is helpful for, I guess, other people trying to get caught up in the things that we're working on too.
Yeah. Yeah. So I think we do not have the finalized version of this IAM thing, but still it's running on our DAM machines. But let me link these resources to the services as well, or EC2, and figure out what service it has access to. Then maybe I will be able to demonstrate something. Yeah. We already have until that from user to what kind of service level access. Now we are trying from the other way around, from resource to resource access, and I will be able to showcase it to you guys in one of the meetings. I think you guys will really like it.
Sounds good.
All right.
Already cool.
It's like I think